Welcome friends to my YouTube channel Sommo Physics. On my previous lecture I told about Kepler laws and their derivations. Now in this lecture I am going to discuss about the standard conic section equation of ellipse. Okay, the standard conic section equation of the ellipse. So let's proceed. We know that angular momentum of a particle in a central force field remains conserved, that is L equal to mr square theta dot, from which we can write theta dot, this is equal to L upon mr square. This is one. Now again we know that the energy of a particle in a central force field can be written as half mr dot square plus L square by 2 mr square plus v. Now on simplifying we get half mr dot square, this is equal to E minus V minus L square by 2 mr square, from which we can write as r dot, this is equal to square root of 2 by m into E minus V minus L square by 2 mr square. Okay, so this we can write. Now if we divide, what we get, if we divide this, we get d theta dr, this is equal to L by mr square into 1 by square root this term, that is 2 by m into E. Now what is V? In case of a central force field, V is minus k by r, so this is plus k by r minus L square by 2 m r square. Now my d theta will be L into dr by m into r square, and this is 2 by m into E plus k by r minus L square by 2 mr square. Okay, so simply we can write it. Now introducing a new quantity u such that r equals to 1 upon u. So what will be my dr? My dr will be minus 1 by u square du. So this can be written in this way, d theta, this is equal to, we get, if we substitute the value of r in terms of u, then we get minus L into du by m into square root of 2 by m into E plus ku minus L square u square by 2m. On simplifying and rearranging we can write this, that means r variable is replaced by u. Now if we simplify it, then we can write minus L into du by square root of 2m, and if we multiply it to all the quantities, then we can write this 2me 2mku minus L square u square. Okay, now divide by L, that is we get du by square root of, here it will become L square, that is this becomes this. Okay, so rearranging what we get, if we rearrange this, then we can write as du by integration, this can be written as square root of something square minus something square. Now what would something, this is u minus mk by L square, and this term will be 2me by L square plus m square k square by L to the power 4, that is minus du divided by square root of 2me by L square plus m square k square L to the power 4 whole square minus u minus mk by L square whole square. So integration dx by root over a square minus x square, this form. Okay. Now if we integrate the above expression, then what we get? We will get theta, this is equal to, we all know that integration dx by root over a square minus x square means sine inverse x by a, and since there is a minus sign, it will become cos inverse x by a. What is x? My x will be u minus mk by L square, and this is what? This is, what is a? A is 2me by L square plus m square k square by L to the power 4. Okay. Now if we simplify it, then we can simply write u minus mk by L square, this is equal to square root of 2me by L square plus m square L k square L to the power 4 into cos theta. Okay. Now again rearranging, we can write u, this is equal to, we take mk by L square common, so what we get? 1 plus L square by mk into root over 2me by L square plus m square k square by L to the power 4 cos theta. Okay. Now what we can write? We can write mk by L square, this is equal to 1 plus, if we simplify it, then it becomes 1 plus 2e L square by m k square cos theta. Okay. Now simply, what is u? U means 1 by r, and this term is nothing but small l, and this we can write as epsilon cos theta. So this is the standard form, this is the standard form of conic section equation. And what is L? We know L is nothing but mk by L square. This is known as the semi-latus rectum, semi-latus rectum of conic. Okay, semi-latus rectum of conic. And what is my epsilon? My epsilon will be square root of 1 plus 2e L square by mk square. This is called eccentricity of the conic. This is called eccentricity of conic. Okay. So we derive the standard form of conic section equation, that is 1 by r, this is equal to L into 1 plus epsilon cos theta. Okay, this is the standard form of conic section equation. So we have derived the conic section equation. Okay, now from this conic section equation, it can be easily shown that the energy of the orbit entirely depends upon the major axis. How we can prove it? So let's proceed. When theta is 0, then 1 by r, this becomes maximum, that means r becomes minimum. And what is r minimum? R minimum can be written as 1 by L into 1 plus epsilon. R minimum can be written in this way. Now when theta is minimum, that is pi, that is 1 by r is minimum. 1 by r minimum means r is maximum. So what is r max? R max will be 1 by L into 1 minus epsilon. Now in case of a ellipse, we all know this is major axis 2a, and okay, this is major axis. So this is nothing, 2a is nothing but the sum of r max and r min. Okay, so for ellipse 2a, this is equals to r max plus r min. So if we simplify it, then what would become 1 by 1 plus epsilon plus 1 by 1 minus epsilon. Okay, so this will become 1 upon L 2 by 1 minus epsilon square. 2 cancels. So if we simplify it, then my L will be mk by L square. So what is 1 by L? L square by mk. And if we substitute the value of epsilon square, so this is become 1 minus 2e L square by mk square. So this cancels. So this becomes minus L square by mk into mk square by 2e L square. So L square cancels, cancels, and there is k, that is minus k by 2e. Okay, so from which we can easily write, so what we get a equals to minus k by 2e. So from which we can easily write e equals to minus k by 2a. So this is the result. So in case of a elliptical orbit, we can easily see that the energy of the orbit solely depends upon the major axis. Okay, so in my today's video we shall discuss about the derivation of conic section equation, and by using that equation we also prove that the energy of the orbit solely depends upon the major axis. Okay, provided that the orbit must be elliptical in shape. So dear guys, if you don't subscribe my channel, then kindly subscribe it and share it to your friends, neighbors. Okay, so thank you very much.